Alrighty guys, so welcome back to my YouTube channel that makes no money. So today we're going to be talking about simplifying square roots. And so first thing we want to do is kind of review what the word simplify means. Okay, it does not mean actually solve. It means just really just to make whatever it is we're talking about, make it easier to look at. Okay. Make it easier to look at. I would rather deal with smaller numbers than numbers in the hundreds or thousands, right? Just to make things more simple, right? That's the root word. So when we simplify square roots, well, this is what we're talking about. So say I have the square root. This is your symbol, right? Square root symbol. It looks a little bit like division, but it's not. It's loosely, like very loosely related to division. I do not want you to think this is like division, right? That'll just make things confusing. So this is called the radical. All right. It's also called the square root symbol. Square root symbol. There is a tiny 2 here, but that's not really, I mean, I guess it's a little relevant. I can just put it. There is an invisible, let me make it red. There's an invisible, what, let me just erase the whole thing and start the, because that's ugly anyways. This is the radical symbol, okay? Now, there's a tiny 2 here, and it's invisible. You never really see it. You never really see any number there unless it's like a cube root or a quad, you know, a fourth to the fourth root or whatever. But if it's 2, it's actually, the 2 is implied. All right. Not really super critical for our lesson today, but it's good to know. And so one more time, this symbol is called the radical. It's a radical, aka square root. Okay. And so before we kind of go into like the math, you need to know your list of numbers. They're a special type of number. Just like there are even numbers and odd numbers and prime numbers, there are what we call perfect squares. Perfect squares. Perfect square. Oops. Perfect square. They're a very special type of number. Okay. Here's the list. Oh, well, there's 0. 0 is obviously 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. These are the most common perfect squares. It's good to have these memorized. These are your perfect squares in the green. This is your list of perfect squares. Okay? And so make sure you have this listed on your paper because I'm going to be talking about these types of numbers a lot in this video. So I'm going to go to the next page. And so when you simplify square roots, so there's 2 types of problems. And I'm not going to talk about whenever there is a negative on the inside of the radical, like negative 22, for example. I'm not talking about that today. Those involve complex / imaginary numbers. Okay, I'm not talking about today. I'm talking about real numbers, rational numbers. I am not talking about imaginary numbers. Okay, so you know what? I'm going to make this. I'll put the list here. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. There you go. Okay. Alrighty. In the green are your perfect squares. It's great to just have them for reference, for quick reference. Okay? So without further ado, so say, okay, our first example. Well, before we do that, actually, I want to talk about this. This you should know also. Okay, these are need to know. Your times tables, very important. Alright, so in the red is how you find the perfect squares. So remember, the perfect squares are in the green. In the red is how you find the perfect squares. You just square a number, right? That's what you call when there's an exponent of 2. You square a number, any number, you're going to get a perfect square. That's your answer, is the perfect square. That's a perfect square, that's perfect. These are just how you get to the perfect square. So make sure you have that. I'm going to move on. I'm going to go back to this list. So say you have, I'm going to do a few examples. Say your first example 1, you have the square root to simplify. They want you to simplify the square root of 81. Okay, so your first step is the number on the inside a perfect square. It's the first thing you always want to check. Is it going to be found on that list of perfect squares? So if you don't already know, let's check it. Oh, and there it is. It's right here. It is on our list of perfect squares. And so that makes life really, really easy. When it's a number that on the inside that is a perfect square, the answer is just 9, or whatever this number is. It's not 7 squared, it's 7. It's not 9 squared, it's just 9. All right? And so when you go here, since 81 is a perfect square, your answer is just 9. This is technically the right answer, but for my class purposes, at least for this lesson, that's not something that we need to discuss right now. So let's do one more. Example 2, it wants you to simplify the square root of 25. And so remember, your first move should be, is the number on the inside, is this number a perfect square? And it is. And so just check your list. Check your list. If you don't already have it memorized, that is your answer. Just 5 alone. Okay, so very, very simple. Alright, just 5 all by itself. So life is really easy when the number on the inside is a perfect square. It's really clean and simple. But what happens when the number is not a perfect square on the inside? So let's do a few of those. So, example 3. Who wants you to simplify the square root of 75? And so, again, your first move should be, is this number a perfect square? And it's not. It's not on our list of green numbers. And so this is what's going to happen. This is how I recommend you set it up. I'll do purple. So I'm going to rewrite the question. And so this is what I'm going to do. I'm going to create a factor tree, not a prime factor tree, just a list of all the factors. Okay. We always start off with 1 and the number. 1 times 75 gives me 75. Does 2 go into 75? No. So I'm going to skip 2. Okay. Let's move on to 3. Does 3 go into 75? Yes, it does. It goes into 75 25 times. 4. Does 4 go into 75? No. Does 5 go into 75? Yes. It goes in 15 times. And, you know, some of them you are going to, if you aren't really strong in your multiplication, you might need a calculator to, to double check. But you just go straight down the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you're going to keep going until the numbers start repeating. And so you'll see what I mean. So, does 6 go into 75? No, it doesn't. Does 7 go into 75? No. Does 8 go into 75? No. Does 9 go into 75? No. Does 10 go into 75? No. 11? No. 12, 13, 14, 15. And we're back to 15. So once your numbers start repeating, that's how you know you're done with a tree. And we'll do more trees. Alright, so now we finished with our tree. Make it green, like trees. Okay, so now the goal is to circle all your perfect squares. This is where that list comes in handy. So that's a perfect square, and that's a perfect square. And those are all the perfect squares. And so now, pick the biggest perfect square. And it's obviously 25. So that's what we're going to use, 3 and 25. So I'm up here. I'm back at the original problem. Square root of 75. Put your perfect square first. All right. Now. Okay. Since 25 times 3 gives me 75, it also follows, okay, it also is true that the square root of 25 times the square root of 3 equals the square root of 75. That's just one of the many magical things about math, is that it will work. And so we're going to use this now. So how I lined it up, that square root of 75 equals square root of 25 times square root of 3. We know what the square root of 25 is. The square root of 25 is 5. And this little square root of 3, it literally just gets dropped, attached to the number, because this square root of 3, it cannot be broken down anymore. It's a prime number. Prime means only 1 and 3 go into 3. So this is it. This is our answer, guys. This is how you simplify radicals. And we're going to do more. We'll do a few more. All right, let's do another one. We're going to simplify 18. So, first things first, check if this number is a perfect square. 18 and it's not. And so that's okay. When it's not a perfect square, we're going to make a factor tree. So 1 and 18. 2 goes into 18. It goes into 18 9 times. 2 times 9. 3 goes into 18 as well. 3 times 6 gives me 18. 4 does not go in. 5 does not go in. 6 goes in. It goes into 18 3 times. But we have 6 and 3 already. So we're done with the tree. And so remember now, our next step is to circle all the perfect squares. So there's 1 and there's 9. And those are all the perfect squares. So the key is to pick the pair with the biggest perfect square. Well, that rhymes. Okay, put the perfect square first. All right, so now square root of 9, we all know the square root of 9 is 3. Just goes straight down, and then the square root of 2 does not break down anymore, so we just leave it. Okay? You literally just leave it. The other chunk, whatever this is, with this method, that's the great thing about this method, you don't have to mess with the second piece. You literally just drop it. That is one of the nicest things about this method. Okay, and you're done with simplifying square root of 18. That's your answer. So let's do another one. Let's do square root of let's do 28. All right, so first things first, make sure 28 is not a perfect square, which it's not. So now remember, the first thing we're going to do is make a factor tree. 1 and 28. 2 does go into 28, goes into 28 14 times. 3 does not go in. 4 goes into 28 7 times. 4 times 7 gives me 28. 5 doesn't go in, 6 doesn't go in, and 7 goes in, but we have 7. So we're done with our tree. Let me make that prettier. So we're done with our tree. So remember now, what we do is we circle all the perfect squares, 1 and 4. Now remember, the key is to pick the biggest perfect square. That's the pair you're going to use. Now I go back up here. I write the perfect square first. Okay? So now I literally just work vertically. I work straight down. I know what the square root of 4 is. The square root of 4 is 2. Go straight down. Like I said, with this method, you don't ever have to mess with whatever this is. So it just goes straight downstairs and you're done. Let's do one last one. Okay, just for fun. Let's do square root of 50. I like 50. So make sure 50 is not a perfect square, which it's not. So 1 and 50, 2 and 25, 3 does not go in, 4 does not go in, 5 goes in 10 times, 5 times 10. 6 does not go in, 7, no, 8, no, 9, no, 10, and well, we have 10 and 5. So we're done with our tree. So now we circle all the perfect squares. All right, and that's all of our perfect squares. So we choose the pair with the biggest perfect square now. That's what we're going to use, 25 and 2. Personally, I like to put the perfect square first. Square root of 25 times the square root of 2. But we know what the square root of 25 is. Okay, it's 5. And remember I said we don't mess with this, so it's literally just dropped. And we're done. So, guys, that's really it. This list is honestly, it's like the most important thing. You just have to know the perfect square numbers, and you'll be fine. These obviously, like, they work out really nicely when when the number inside the radical is a perfect square, but most of the time they will not be perfect squares. So, that's when you have to make the tree. Pick the biggest perfect square, so use the pair with the biggest perfect square, and then write it in this way, right? In this way. Square root of 4 times square root of 7, and then just work vertically, work straight, like downwards, to get your final answer. And that's really it. So don't overthink it. Don't, be your own enemy. And yeah, that's really it. And I'll see you guys at the whatever next video I make. Okay, thanks for watching. Bye.